So let's look at 18 here. We are going to first see, if I look at this right now as it is there anything that can simplify right now? Do you have your perfect chart out? I only see like 5 people with a perfect chart out. Get it out. Yeah, so 18 divides by a perfect square of 9. And so we would want to go ahead and do that. Split up the square root of 18 as 9. Square root of 9 times the square root of 2. Okay, we're going to rewrite this then, okay? I'm not going to do anything with the top right now. The numerator stays as 4x plus 2 root x. The denominator, though, since the square root of 9, you can take the square root of that, right? So it's 3 times square root of, it would be 2x, because there was an x in there as well, if you see it in the 18. Okay, not very pretty. Now we have to do what's called rationalizing. Remember, if I see a root, this is no good. You have to multiply by that same root if you want it to go away. So in the denominator, I have square root of 2x. Yuck. So we're going to multiply by square root of 2x in the numerator and denominator. Okay, this is not going to be very pretty, but it's going to be okay. We're just distributing, okay? So in the numerator, I do, remember, outside numbers multiply to outside and inside to inside. So 4x times the square root of 2x. Can't do a whole lot there. It would look like this, 4x root 2x. One's inside, one's outside. They are not friends. You do have a little bit of multiplication. You can multiply here, the insides together. So on the outside, you have a 2. And then on the inside, you're multiplying, I'll highlight, x times 2x. What's that? 2x squared. Okay. That's going to simplify. Okay, and then in the denominator, you have, multiply these things together. 3, and then you have to multiply the 2x's together. So square root of 2x times square root of 2x is square root of 4x squared, which should be a perfect square, and should you be able to take the square root of that? Okay, so here, I'm going to write it in. So square root of 4x squared is 2x. Because the square root of 4 is 2, the square root of x squared is x. So it's going to rewrite like this. Okay, this is kind of yuck. In the numerator, you have 4x root 2x. How about this? The 2x squared. The index here is 2, so divide by that. That one simplifies a little bit, right? So plus 2, and then it'd be out in front, x to the 2 goes into 2 one time, so x the first. And there's still a little bit of remainder here of square root of, it's square root of 2, right? Yeah, square root of 2. Gross. Okay, and then the last part here is there supposed to be an x in that one? Hold on. No, that's right? Okay. And in the denominator, you have 6x. All right. You just check and see, okay, can I simplify any more? Can I combine like terms on the top? Are those the same? They kind of look like they're sort of the same. But do you see how it's square root of 2x and square root of 2? So close, not the same. So no, you can't combine them. Not really anyways. You could cancel out the x's here, since it's like the triangle thing you had for quadratics. So I could go x, x, x. And then all of those could go away. And so it just becomes a little bit simpler, which if you hadn't caught that, it's okay. Oh, and you also can divide all of these numbers by 2. You see this? 4, 2, 6. All those outside numbers. So we can divide them a little bit further. And the final answer becomes square root of 2x plus 2 root 2. No, wait, I can divide. Okay, divide by 2. 2 root 2x plus, I'm sorry. Division's not good today. That would be square root of 2 over 3. Woo! Once you figure out what you're multiplying by, you distribute it, and then you just have to keep simplifying bit by bit until there's nothing left that can be simplified. There's not like one right first step. If you missed the simplifying at the beginning, like with the 18, you could have multiplied by square root of 18x, and it would have been fine. It would just mean that you have bigger numbers to simplify when you're done. We're going to fill out this little fill in the blank section, and then we'll do 2 of the binomials, and if it's confusing, that would make sense. It is tricky. Okay. We are multiplying by the conjugate, which remember we've done with i's before. We have done the same process with i's actually. Multiply the conjugate, which means the same terms that are in the binomial, but an opposite sign. Opposite. So you're going to use the difference of squares. That's how it's going to work out, as a difference of squares. If you can catch on to that pattern, that's great. Use a difference of squares pattern to rationalize. You just end up having to actually multiply the first and the last terms, and the middle terms will cancel out. You'll see that happens every time. Here's what I want you to see before we move on to the next problem. What we just did is, you can see at the top of that section, it says that you're dealing with monomials. So the denominator here is a monomial, meaning it has one term. If it has 2 terms, then you have to do it with a conjugate, okay? So we'll look at 19 and 22. Questions on the last one. You have 2 terms, and so you have to rationalize with the conjugate because there's 2 terms there and not just 1. So since I have 3 plus root 2, the conjugate of that is 3 minus root 2. And you have to multiply by that on the top and the bottom of the fraction so that you keep it equivalent, because that's really just multiplying by 1. You have done this before with i's, I promise. It's actually the same process. It's just that you have roots now instead of i's. Okay, when you're multiplying, make sure the outsides multiply together and then the stuff inside the radical multiplies together. So here, this is fair game. 5x times 3. What do we get? You can do it. 15x. You're doing it. Good job. Okay, we're not going to be scared. It's just a square root. We're also going to multiply 5x times square root of 2. 5x is an outside number and root 2 is an inside number. Can I multiply those together and get 10x? No, because one's on the outside and one's on the inside. They are not friends. So it's going to be like this. Minus 5x root 2. Do what you can, but if you can't do anything, then you stick them side by side. It's fine. Okay. Now, this bottom part, this is where it gets ugly. And I don't know about you, but if I have to distribute this right there, then it's going to get really messy. So I'm going to do the box method out to the side, just so it's not too terrible later on. Okay? If you want to do it right there in the problem, you can. I just don't want to. So it's going to be 3 times positive root 2 and 3 times negative root 2. Do you see where I'm getting these from? Okay, it's those bottom 2 binomials. I'm just multiplying it in the box method instead of straight up in the fraction, so I don't have to write it out so many times. 3 times 3 is 9. 3 times root 2 is positive 3 root 2. 3 times negative 3 root 3 times negative root 2 is 3 negative 3 root 2. Do you see what's going to happen to those two? They're going to cancel. Okay, and then in square root of 2 times negative square root of 2 is negative square root of what? 4, which is going to work out nicely, right? Okay, so the good news here is that when you do multiply by the conjugate, these cancel out because positive, negative, 3 root 2. What is this box? Negative square root of 4. Negative 2. Please don't tell me it's 2i because the negative's out in front. Okay, so what is this actually? It's just 9 minus 2. Yeah, 9 minus 2. Which is 7. Great. Can you combine like terms in the top? No, so that second term has a square root of 2, first term does not, and so that's unfortunate, but no, don't try and combine them and get 10x. You can't do that. Okay, so that stays 15x minus 5x root 2 over 7. And you just check these numbers, just like the triangle of the outside numbers, 15, 5, 7. Can I divide any of those? Nah. And so that's it. That's as far as it goes. Here's how you know you're done. There's no more radicals in the denominator. You can't simplify square root of 2 anymore. And there's no roots of a fraction. So that's it. Yeah. Okay, so this is a binomial, has 2 terms. You do the conjugate of the bottom one because you are not allowed to have a radical in the denominator. So what is my conjugate? So same term, so square root of 5, square root of 3, but I'm going to have what in between? Minus. There you go. Okay, and you have to multiply that top and bottom because that's the only way to make sure that it's still equivalent. You're multiplying by 1. Okay, again, just like the last situation we had, you could do this all right here. It would just be really messy. Or you could do the box method out to the side, and I would do it twice because you have 2 things to distribute. So the numerator I'll do first. I'll just leave space because we're doing 2 box methods here, okay? Here. The first one is 5, negative root 5. You good? Okay. And then square root of 5, negative square root of 3. Gross. Okay, here we go. Outside to outside, inside to inside. Okay, so 5 root 5. And then 5 times negative root 3. You cannot multiply those together. So it's negative 5 root 3. That's what the multiplication would look like. I should have made my boxes bigger. Ooh, this one is going to work. Negative square root of 5 times positive square root of 5. Ooh, you're multiplying. So it's going to be negative 5 because of, right now, it's negative square root of 25. Do you see why I multiply them together? They're both inside numbers. Okay, and then this last one is negative times a negative, so positive square root of what? 15. There you go. Okay, you're doing it. I don't think anything cancels, does it? Yikes. But this negative square root of 25. What's the square root of 25? So this is just negative 5. So you don't want to leave it as a square root if you can actually evaluate it. All right, that was the top. And unfortunately, none of these are like terms because we have 5 root 5 minus 5 root 3. I'm going to go ahead and do the root 15 next. And then the constant at the end, minus 5. You can't combine any of those. And you can't simplify the square root of 15 because the only options to divide by are 4 and 9. That's unfortunate. Okay, so I'm going to let you do the next box. We're multiplying the conjugates, which stuff, when you multiply conjugates together, stuff should cancel out. So when you go to do this one, it should work out beautifully, okay? You should have something cancel out. Okay, try at your table. Do you see some stuff that will cancel? Yeah, the root 15s, right? Positive, negative, root 15. And then these other ones will simplify because square root of 25 is 5. And square root of 9 is 3. So this one becomes negative 3. So when you go to your fraction, you're really just going to do 5 minus 3, right? Which is 2. And you just double check that and see, okay, can I simplify any of those outside numbers? 5, 5, 5, 2, no. Not very pretty, but the good news is you're done. Because none of those radicals simplify further. There's no radicals in the denominator. There's no radicals of fraction. That's all you can do.